Okay, continuing on. I thought it was a good place to stop earlier since this page didn't properly load. We talked a little about sockets, so let's talk about. We talked about that the socket needed to talk from the application and send the data from the application uh, through the network. So how does it do that? So to do that, you have to have some sort of addressing scheme. So basically, in TCP/IP networking, we've had each host be identified with a 32-bit IP address. Of course, I'm talking about IPv4. We are going to talk about IPv6 later on when we get to um, future lecture. But for now, each host has a unique IP address that's 32 bits long. However, since you can have multiple processes running on that host that have to communicate supporting different types of applications, we have to have more than just the IP address to make distinctions in our communications. So because of that, we have to have the concept of an IP address and a port number. So the IP address corresponding to the host and the port number corresponding to the process on the host that's doing the communicating. And basically, we have the concept of the well-known port number, which we're going to talk about, but there are specific port numbers that are set up for particular applications. For example, an HTTP server uses port 80, a mail server uses port 25, and so these are all predefined port numbers up to 1024. So as an example, if there is a web server at a particular host name, it has a particular IP address, in this example 128.119.245.12, and a particular port number. So next up we have an example. So in our communication, we usually start off with some sort of English readable name, basically a host name. For example, say you want to go to Google, you type in www.google.com on the web browser. The domain name system translates that into an IP address. And because of the fact that you're doing use a web browser, you're going to use a particular port. In the case of HTTP, you're going to use port 80. If you were trying to do an FTP connection, which you actually probably couldn't do because of security reasons, but if you were going to do an FTP connection to the google.com host, you would use port 21. And we're going to see these things in our Wireshark lecture, see examples of the port numbers being used in the communication between hosts. But basically, you're going to use an IP address to get you to the host, and then a port number to access a particular application that you need to access of that particular host. So an application protocol, to kind of review a little bit, it defines the type of messages, where there's a request and a response, so that has to be some sort of communication defined between the two end stations. Then you have a message syntax, what fields are in the messages and how the fields are delineated, so each application layer protocol is going to have different message syntax that we're going to see. Then there's obviously the message semantics, so you have your fields, and then you have the meaning of what the fields mean. So each application layer protocol has some sort of basically data definitions that include both the syntax and the semantics. So the syntax is the type of messages that are being sent, and the semantics is what the information in those message fields mean. And then finally, an application layer protocol has to define when and how to process both send and response messages. So those are the basic functions of an application layer protocol. So most protocols are defined usually by the IEEE. They're defined in different RFCs. One thing I'm going to try to do in this class is to actually put links to the different RFCs that we're going to discuss as we go through the course in the additional material folders for you to take a look at. And so because these are open protocols, that means any developer can use them to develop their applications that are going to communicate. So anybody developing web applications will use the protocol defined for HTTP. Anyone developing email servers or email clients will use the RFC developed for that, etc., etc. And we still have, in this day and age, also proprietary protocols. For example, Skype has a proprietary protocol because it's an understanding that you're only going to do that communication between two Skype peers. So sometimes there are proprietary protocols as well as open protocols. Okay, so based on how the application is going to work and what its requirements are, there's going to be different and kind of conflicting requirements. So we're going to probably use different transport services depending on what the application is going to do. So we're going to look at three factors: data integrity, timing, and throughput. So data integrity, so when you think about it, if I'm sending a file from one person to another, so I'm sending a document, say, for example, I need 100% reliable data transfer. I need all the information in that document. I can't have words missing. I can't have words garbled. I have to have something 100% reliable, or it's not really useful. However, if I am on say a Skype phone call, or if I'm using my Ooma phone over the network, I'm talking to somebody, and my words gets a little garbled, here and there, as long as it doesn't happen all the time. But every once in a while, there's a little static on the line, or I'm watching a Netflix video, and there's some crackling on the screen or something. I can live with that. That's not data integrity is not as important in that case. So those are kind of conflicting requirements. Another one is timing, and this is kind of just the opposite. If I'm sending a file from one person to another, it doesn't matter how long the file it takes to get the file at the other end. I don't have any time requirements as long as they get it eventually. If I'm sending an email to somebody, it doesn't really matter how long it takes to send the email. However, if I'm playing an online game, or I'm on the phone, or I'm streaming a Netflix video, timing becomes important. If I talk to somebody, it takes 30 minutes to get the response back. That's not going to cut it. So the usefulness of the application has different timing requirements. So it's kind of the opposite of the data integrity. And then there is the concept of throughput. So if you're doing, especially multimedia, you're trying to send a video, onto a screen, so you have to have, even if you're using some sort of compression, you have to have some minimum amount of throughput in order to be able to, see that video and have it, refreshed at a decent refresh rate. If I'm sending a file, I don't necessarily have a specific throughput requirement. My throughput can vary, and I really don't care. And then in general, there is encryption and data integrity and security issues, and that probably goes more onto the, well, that could vary. That you might need security all the time in one way or another. You don't think you really need security to, for a Netflix video to be useful, but you do in a sense that you wouldn't want, sending a video to your computer to, download a virus. So I think all applications have some level of security. But obviously, if it's something, data integrity the data integrity part of that comes more into play when you're dealing with, you don't want your data to be changed. That's more important in the file transfer paradigm. So here we have a nice little chart, basically kind of puts in detail kind of what I was talking about of the different transport service requirements for common type of application. So I kind of already talked about this, so I'm not going to belabor the whole table. But basically, things where you're basically just sending data. The data itself is important. You can't have any data loss, but you don't really care about the throughput, and it's not time sensitive. When you are looking at more interactive type things where more basically processing sensitive interactive, so not text messaging so much, but audio and video, interactive games. You can be a little bit lossy, but you have some throughput requirements. When you get to text messaging, you can't lose the data, so similar like a file transfer. It can have elastic throughput because you're just sending text. But that one's kind of odd because you're communicating back and forth. There's some level of time sensitivity. It can't take, if you're doing a live text message and the person's connected, it can't take 30 minutes to send a text message back. So there's some level of time sensitivity. It's not as high as a voice over IP telephone call, but there's some level of time sensitivity with that. So basically, based on your requirements, you're either going to use a TCP or UDP. So traditionally, and we're going to talk about this more in future lectures, but just really quickly, TCP is going to be used mostly for when you require reliable transport. You can't lose any data. TCP will provide some flow control where the sender won't overwhelm the receiver. So sometimes we actually need that with the UDP service, and usually the application has to provide that flow control. So flow control is either at the TCP level or at the application level. Then you have congestion control because, of course, you don't want to drop. If you have a reliable transport, you can't afford to do too much dropping and retransmitting. So you have to have some congestion control. We're going to talk about that in the future. TCP by itself does not provide timing, any type of minimum throughput guarantee, or security. You basically have to have the application provide that. And TCP has the overhead of the fact that it's connection oriented, so there has to be some sort of setup between a client-server process. UDP, a little more stripped down, provides unreliable data transfer. So if you miss some data, it's not a big deal. and it really doesn't provide much of anything. And so if you need to use UDP because you don't want the overhead of having a connection-oriented setup, but you need some of those things like reliability, flow control, etc., your application has to provide those capabilities. And so basically this is an overview of what we just talked about. I'm not going to go through it. You can go back and take a look at this as a copy of this lecture in the initial material, but this kind of summarizes what we just talked about. And this shows more specifically the different applications and their protocols. Most of them are open systems protocols with an RFC defined, and it shows the underlying transport protocol. And you can see that internet telephony is often proprietary, and there's not really a RFC for that. So you have that basically something that you have to address using proprietary software and or equipment. And you can see the different transport protocols. And you can see that with streaming multimedia and internet telephony, you can use either TCP or UDP. And there are some, we'll talk later, there's some advantages to using either or. And basically, sometimes TCP can be a little bit slow, but you need some of the features of TCP. So very often you end up using UDP to deal with the performance issues, and your application provides some of the services that TCP normally provides. And when we get into multimedia, we'll address that in greater detail. So securing a TCP, I'm going to skip this for now. We are going to talk about this in greater detail when we get to the cybersecurity section. And basically, this kind of summarizes what we've talked about so far. Peer-to-peer application are more scalable than client-server. Applications exchange messages using operating system sockets. I'm going to talk about that in greater detail shortly. Applications communicate using host names, which get translated into addresses and have particular ports defined for particular applications. Applications use transport on either TCP or UDP, where TCP is used primarily when you have we require reliable communication. I can't lose any data. And UDP is for loss-tolerant, delay-sensitive applications. Okay, so the next thing we're going to talk about is we're going to talk about the web and HTTP. This is going to be the first application we're going to go over. So we're going to talk about the web and HTTP, file transfer protocol, the electronic mail protocols, domain name server, PDP, socket programming, and I know it's not on here, but we're also going to talk about network time protocol. And I think now would probably a good time to take a quick break, and then we will continue.